Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by StrongDM. Manage and secure remote access to any database, any server, on-prem or in the cloud, and environments. They make it easy for DevOps teams to enforce the security and controls InfoSec teams require. So if your engineers need access, you need StrongDM. So what can StrongDM do for your team? First off, more control, less hassle. Grant or revoke access to any database or server in one command. Use your SSO to manage access to every database, every server and environment. Second, total visibility. StrongDM upgrades your audit logs, log every permission change, every query, every SSH, and every RDP command, and know who issued those changes. And of course, faster SOC 2 compliance, easily enforce access controls, and instantly answer auditors' questions. Head to strongdm.com/GoTime to learn more and request a free demo. Again, strongdm.com/GoTime. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Well, hello there, and welcome to Go Time. I'm Mat Ryer, and, thanks for listening. Thanks for putting this podcast in your ears every week. It's much appreciated. Today, we're going to be talking about the art of execution, how we actually get things done. Is there a right way and a wrong way, or is it, as I suspect, more dependent on team dynamics, personalities, context, and sort of other interesting things? Let's find out. We're gonna dig into this and get to the bottom of it once and for all. And doing that with me are three Gopher detectives, two familiar voices and a new one, I think, for the show. I'm joined first of all by Johnny Boursiquot. Hello, Johnny.
Hello there.
How's it going?
Well, it's going well. I've had some excitement recently. Started a new gig.
I saw a tweet. You're moving jobs, right?
Indeed, yeah. Officially an SRE for Heroku, owned by Salesforce.
Interesting. That sounds exciting.
Yes, and you can bet I'm going to have opinions on this dev process talk of yours.
Good. Well, you can share them with me, and we're also joined by a regular on the show. It's only Jon Calhoun. Hello, Jon.
Hey, Matt.
How's it going?
Pretty good.
Great. What have you been up to, mate?
Just working on new course website stuff. So I'm really interested to talk about this, especially because, Johnny working at Heroku and me working pretty much by myself, I imagine our processes are going to be pretty different.
Well, we'll find out, yeah. And somebody else who's joining us today was somebody that I met in person for the first time at the recent GopherCon EU conference in the Canary Islands. Beautiful place for a conference, by the way. It's Egon Elbre. Egon, how is it going?
Oh, it's going delightfully.
I'm so glad to hear that. Would you like to pronounce your name in your voice, just so that we know how it really should sound?
Sure. Egon Elbre.
Elbre.
Close enough.
Close. Exactly.
I'll accept that.
In my ears, that was exact, but no, fair enough. Yeah, so what did you speak about at the GopherCon EU?
Oh, I did a talk about psychology of code readability. So how we kind of analyze and see code and what we can learn from psychology and how to apply to code writing.
Yeah, and that video will be available online, so I recommend people search for that. It was a great talk, very interesting, and quite an interesting subject that I haven't seen before, actually.
I don't think it's a new concept in that sense, but yeah, it's not widely talked about.
Yeah. No, but I recommend it. It's very interesting. So why don't we just jump straight in and talk about development process? And I think we can mention what it's like working in teams as well, if that's part of it. But I have a feeling that team dynamics and things might even be its own show, because it changes things quite dramatically. But that'll depend. I mean, Jon, you mentioned that you work primarily on your own. Is that your choice, or will no one work with you?
I don't know. I don't know if people still work with me or not. I haven't tried in a while. No, most of the time it's just what I'm doing. It's just hasn't been enough work to justify more people. You know, I have historically worked with other people, and I can get other people occasionally. It just hasn't been as much what I've been doing lately. Yeah.
You did some work with Egon, right?
He did the illustrations for my testing course.
Ah, so Egon, you illustrate as well as write code.
Oh, yeah. That's one of my hobbies.
Nice.
He's one of the people who are blessed with both the artistic talent and the coding ability.
Yes. Yeah, I usually don't like those people. But no, you're right.
I completely understand.
Well, I love the artwork in Jon's courses, actually. I've always, it looks nice. And it's a cool, interesting way of contributing as well for people. I know Ashley makes this point that if you're young in the community or you're new to the community, and I know this doesn't quite apply to you, Egon, but if there are people out there that have other skills that aren't directly coding skills, you'd be surprised how useful they can be and how much they can add to a project. So that's very cool. Right, so development process. One of the things I tend to do is rewrite code. I read a thing ages ago talking about writing novels, and it said the art of writing is rewriting. And that, I think, applies to software as well. Every time I rewrite something, the second time I write it or the first time I rewrite it, it's significantly better because I've figured out a lot of the things kind of in the first draft of it. So usually my first draft isn't production ready, but I have everything sort of fresh in my head, and then writing the second one allows me to either fix any design assumptions that were wrong, or just do a better version of what I've done. Does anyone else do that?
That's probably, yes, absolutely. And I think to add to that, the more time goes by, I think the clearer the sort of it becomes of what the rewrite should be. It's kind of those things that the more you work with the system, especially if you actually get to put it in production or derive some value out of it, the more you see it actually work in the real world, that feedback is going to allow you to rewrite it sort of better next time. So there might be a slight difference in terms of how you were sort of originally presenting it. Basically, I'm not sure if you meant that basically if you write it today, tomorrow you wake up, you're like, hey, I'm going to rewrite this, and I know exactly how to do it. Because I've slept on it. I know I've had a chance to sort of think about it. I know what to do with it, right? And on my side of the fence, it's more of a actually after having seen it, right, in action, right, and getting that sort of feedback and knowing, okay, this is how it behaves today, and this is how it can be better tomorrow. So I think that element of time sort of adds sort of an extra level of clarity to what you were saying.
Yeah, actually, I pair a lot with David Hernandez, who was my co-founder of Machinebox. And we basically almost exclusively at the moment program everything. And one of the rules that we set ourselves is a cool-down period. So whenever we have an idea for something, we get so excited about it, we really do just want to get in and start doing it and start writing code and building it. And we sort of have to force ourselves to just take a step back and let the idea cool down a little bit. This applies to adding features as well as new things, because it's easy to just get too excited and jump in and not really think too much about it. That cool down period really helped us to make sure that what we were going to do was worthwhile. And sometimes we'd say, yeah, do you know what? I thought about it. I'm not sure now. Or sometimes I just don't like that idea. I don't love it. I loved it yesterday and I'm just not feeling it today for some reason. And then other times it validates and we're like, yeah, I even thought of additional things and and we should definitely do it. And, then you can get excited again.
Yeah, I tend to also let those ideas sit and mature, and afterwards the result is usually much nicer. This means that I have these works in progress that take year or more to do. However, while I'm doing other things, I'm learning how I could be doing that better as well.
Yeah. Do you ever do deliberate rewrites of things?
Oh yeah. The more critical the system is, the more I rewrite it. One of those, actually, I did 6 rewrites in 4-5 different languages.
Oh, wow. What was it?
It was a synchronization algorithm between browsers through a legacy system. So, and if you get synchronization wrong at some point, or you switch 2 lines, then all hell breaks loose. So you need this consistency and clarity in your code base.
Well, let me ask you this, Egon. So with that particular project, was there any sort of an upfront design done, or did you figure that you're going to learn what you need to learn in terms of how you need to approach the rewrite, right? With each subsequent rewrite, right? Basically, you're going to figure it out as you go. Because, the reason I ask is that for me, I don't typically tend to go to code first, right? I don't learn what I need to do with code first. I'll probably sit down, maybe do some README driven development, and try to reason through and think through what I'm trying to do before I put down code. And that might be different for different people. And it's not a right nor wrong. I'm just saying that for me, I can't go straight to the code. How was that process for you?
Oh yeah. Before doing those rewrites on the final thing, I also implemented 5-6 different approaches and went through 20 research papers or something like that on different synchronization algorithms. But that's an exception for me, or the extreme case of this rewriting. I usually don't do that much.
I think you might be a bit of an overachiever, Egon.
A bit?
That's interesting you say that. So it needed to be correct, and therefore you paid special attention to it and put a lot more time into that thing. So if there's a little throwaway tool that you're writing, I suppose you wouldn't necessarily give it that same attention. Is that right?
Oh, no. It's often in Slack when I'm helping some people, then I even don't see whether it compiles. So there's definitely this different degrees of correctness that I care about.
Yes, and I find that to be the same as well. Depending on a few things, like how long's this code going to live for? If I expect this code to have a long life, I probably will treat it differently to if I just want to solve a task and I'm going to write a program then run something once. It's very clear whether it's working or not, and sometimes I'll even skip writing tests for that. And I'm a kind of TDD fundamentalist almost. So yeah, I think the context and the lifespan of a code base and things like that, I think all play into these kinds of decisions. Jon, do you ever do things differently for quick, simple things, or do you always have a single process for everything you're building?
I definitely do things differently for simple stuff. That's I don't remember where it came up on Twitter where people were talking about globals and how they're always bad, and I think globals, to me at least, are one of those things that's useful when you're just writing a quick draft of something. I can give you some examples of things that I do that are bad engineering practices, but are helpful for me early on. For instance, if I'm using an API library, I will just hard code my key into my code as a variable for the very first pass. Now, I'll put a to-do there to pull this out on the final version when I refactor, but when I'm just getting started, a lot of the times just using globals and not really thinking about how would I structure this in a useful way is nice to just set that aside for once I see how this all works together, I can refactor it. But right now I don't really know, so it doesn't make much sense to waste the time figuring that out.
Yeah, that's a very interesting point. And I think that applies to other things as well. One example I can think of is I hosted with Ellen Gerbers, I hosted the lightning talks at GopherCon EU. And we wanted a way to select who was going to speak next. So we wrote a little Go program, and I started to use the rand package because I wanted to just have a slice of the names, and I was going to just pick them randomly and have the computer just sort of speak out the name and introduce the next person. So it's kind of a silly little thing. And Bill Kennedy was there, and he came over and said, "You want random? Why don't you just range over a map? Because that's random." And of course, technically that's unspecified behavior, as Peter Borgen was very kind to point out on Twitter. The randomness in a map is unspecified. It's not to be relied upon. And actually, the reason it's there, I think, is because people were relying on the map being like a queue. They were using it with a deterministic order, and that was also a misuse of it, because actually, technically, it's unspecified. The order that Go will range over a map is unspecified. So, but in that case, of course, just for a one-off tool that we were going to run on that day, it worked perfectly. And just ranging over the map selected random speakers. So we got a random order for the lightning talk. So it was really cool. But yeah, it was. Peter made an interesting point that is unspecified.
When you talk about sort of readability, or rather simplicity of code, to me, if I saw that in production code, I'd probably not let it through. If that code was depending on my PR approval to get in, I probably wouldn't let it through, because someone, especially someone who's sort of new to Go or still trying to wrap their heads around Go, if they didn't know this bit of sort of esoteric knowledge about maps and Go, they wouldn't know that this is what's going to happen, right? So there's nothing in the code that says, hey, we're supposed to pick something randomly here, and not just iterate over a map, and because we happen to know that it's going to be in random order every time, then it's going to do what we want it to do. That happens to be the case, but there's not enough sort of explicit sort of called out behavior about that. So
yeah. You should make friends with Peter Borgen, because that was exactly his point. Now, my counter to that, of course, is that the order of the speakers was unspecified, and therefore unspecified behavior was kind of what I was going for. But that was absolutely just trying to get out of it. But yeah, you're right. You're right. You shouldn't do that. And so this is it. Like, how hacky do you end up? Or in the real world, how hacky do you allow things to be if they are just a short-lived little thing just for you, or just for a few people for right now? Or Johnny, do you insist on that quality from the beginning for everything?
There's a certain threshold for sure that I'll have, but I think it's hard for me. If I'm continuously sort of training myself, right, when I write code, I'm saying, okay, I'm gonna write this, I'm gonna do this right, and especially if I'm teaching, right, if I'm teaching something, and if I know I'm gonna teach something, like I don't want to have like a double set of standards, right? It's definitely there's a threshold there where, like John was saying, that okay, if I know that I'm going to replace something, I might sort of hard code something. I'm just playing around. I'm just trying to exploring. But the moment I know that okay, I'm like I've crossed that threshold where I'm no longer playing around, and I know this is going to be a thing, whether it's for production code or for example project out online or whatever the case may be. Once it leaves my laptop, once I commit it somewhere, once I make it public for public consumption, then then basically my mind just won't let me get away with that, right? I have to spend some time sort of making sure that it is following some best practices, that it is doing the right thing, that I'm not going to confuse somebody who happens to be learning from that code or anything like that. So, but that threshold for me is very, it comes up quickly, right? I don't spend a lot. I'm not going to basically build an entire program, entire package without basically at some point saying, you know what, there's enough of these sort of shortcuts in the code that is starting to bother me. But it's more of a, I think I do realize it's more of a personal thing, but there's that threshold, that tolerance for me is very, very low.
So would you say, like, it sounds like what you're saying is part of it depends on the audience. And I think for at least me, a second part of it tends to come down to who's going to become responsible for that code. So like, I mean, you're talking about stuff getting checked in or, going through a PR process or something. I think if code's going to be owned by a team, then you have the right to be more particular, as a team especially. because then somebody else is going to have to maintain it. But like, for instance, like you're saying, checking something in, I don't mind throwing something on my own GitHub profile that's kind of rough, as long as I'm not like advertising it as like, hey, go use this for whatever, or if I'm not clear. A good example of this is like I have the Go for Sizes exercises, and the code there is not good code, right? And well, it's not bad, but there's many cases where things should probably be done differently in a refactor. But my goal there was very much to get people practicing. So I had to like force myself not to go back and refactor and only show them the good version, because I'm like, they need to see that when you're just learning how to program in Go, you know, you aren't going to start with that final version.
Yes, I think I definitely agree with that. Yes, it's and I've done the same thing. Sometimes I'll put up sort of deliberately, sort of not necessarily bad, but not what I would put in production code, right? So just to illustrate that very point, yeah. So in that way, I definitely agree. So the audience, basically that you have in mind for that code, the one thing I'd say is that basically, you know, that sort of caveat must be like, you know, called out, right? So that, you know, they will know, right, what is the intent behind the example or the exercise that you have in mind. As long as that way, they're not going to pick up the bad habits, if you will.
I have a maybe slightly different approach. I try to write as good code as I can during the first run. I just might not rewrite it, because often I've noticed that people copy and paste your code, even if you like it or not. So it's probably nicer for the community in general to have this good enough so that they can copy and paste it. Of course, for learning purposes, having so-called bad code is actually beneficial, I think.
Yeah, it can be, as long as you can have the conversation, I suppose. It's really interesting. It's true, every time we have code that's out in the wild, it is a learning opportunity for people. So that's a good argument for actually trying to make sure your code does do or meets the standards that you maintain, I suppose. It is a learning opportunity, and we sort of do learn by osmosis a lot of the time, but we read something and probably remember it even if it's subconscious. So that's a very interesting point. Maybe I shouldn't have used a map. I'll blame Bill Kennedy.
At the very least, you've probably educated more people about the fact that it's undefined, like an undefined order.
Yes. Well, that's usually my interaction with Peter Borgen on Twitter, is some conversation around something, and I'm perfectly happy to be wrong and be out in public and learning in front of everyone else. I think that's quite a healthy thing for us all to do. And as we've talked about before, I might be coming from a position of privilege by being able to do that. But we shouldn't punish each other for bad code, but it's an opportunity for a conversation and we can talk about it. And I'm always grateful when we do. But yeah, has anyone else ever been told off by Peter Borgen on Twitter?
I wish. Yeah, I mean, I'll echo what you just said. I mean, it's a brief tangent. There's this sort of feeling that Go is sort of elitist, if you will, that basically the folks who do Go are sort of higher than thou kind of thing, like they breathe like rarefied air kind of thing. That's I mean, we have to sort of dispel that whole notion, right? We're all learning. Even those of us who have been doing Go for a while, we learn something new every day about the language. You know, at least we learn what not to do sometimes. So even though folks might not be sort of being sort of public, right? Or perhaps they're not as comfortable as you, Matt. You know, basically saying, "Hey, I'm learning in public. I don't mind being, you know, sort of looking foolish a little bit for the greater good." But you know, I think that's something we should all be doing. I think that's something we shouldn't sort of assume that everybody, you know, we see out there doing Go knows exactly what to do, because that's certainly not the case for me, for sure.
Yeah, I appreciate the conversation, and sometimes it's not about right or wrong as well. In fact, often in software, I find there isn't really a right or wrong. There's usually trade-offs with things, and that's usually what the conversation is about. Whenever I always say this when I do a talk, I say, you know, don't just blindly follow these rules or treat it like some kind of gospel or anything. These are things I do, and there are reasons for that, and you might like those reasons, and they might apply in your case too. That's always my approach with it, and because too often, I think I haven't made that clear. And then people will try and apply a pattern in a place where I wouldn't even have applied it in that particular case. And then they come into some pain with it, or there's some friction there for some reason. But yeah, I think that's all part of the learning thing. And I love having those conversations publicly, especially when two people disagree and they could both be right. I like that too.
This episode is brought to you by DigitalOcean. DigitalOcean makes it super simple to launch a Kubernetes cluster in minutes. The DigitalOcean Kubernetes platform empowers developers to launch their containerized applications into a managed, production-ready cluster without having to maintain or configure the underlying infrastructure. They seamlessly integrate everything with the rest of the DigitalOcean stack, including load balancers, firewalls, object storage spaces, and block storage volumes. They even have built-in support for public and private image registries like Docker Hub and Quay.io. Developers can now run and scale container-based workloads with ease with the DigitalOcean platform. Learn more, get started for free with a $50 credit at do.co/changelog. Again, do.co/changelog.
So we talked a little bit about design and upfront design and things. Some people, and I think more traditional waterfall kind of dev teams like to do big design. They design the entire solution in documents first, or something that's really sort of low fidelity, so it's very quick and easy and cheap, that you can have this thought process. And then in a waterfall world, that would then go into development, and then later that would go into test, and then whatever, and into release and into production or whatever. I always prefer iterative development. For me, I learn by doing, and I design often by actually implementing it. And I think that there's something to be said for the feedback you get from your code as you're building something. How do we feel about how much upfront design do we do versus just jumping straight into the code?
I'm assuming by design you probably mean like design doc type, maybe not design doc, but thinking about the entire system. But what I tend to use, a lot of the times I'm working on web pages, so I've found that most of my upfront design work is just sketching out all the pages that I'd expect to have and sort of all the interactions I'm expecting. And I might not do them all. I might decide like, all right, I need an authentication system that supports all of these things. Let me sketch that out real quick. But for whatever reason, I find that whenever I sketch the things out at a very, like not, pixel perfect design or anything, but like a high level, it really helps me reinforce what type of data I'm going to need, at different pages, how those interactions are going to work. And it helps me later when I go thinking about the entire system and how I'm going to actually code it, it helps me really verify whether or not something will or won't work. Because I can be like, well, that's not really going to, blend well with this design.
Yeah, I tend to do like large-scale sketches, but not design per se. So this is to understand the wholeness of the system in a sense, so that things will fit eventually together nicely. But going into detail at that large scale probably would create so many errors because I'm missing so many details at the lower level. And yeah, from there on, I would go from starting to implement those smaller pieces incrementally, gradually building them up.
Yeah, so that makes sense. If you have an existing system that's quite big, then that probably changes how you should approach the design bit. Whereas if you're just starting on something completely fresh, then I think that might change it. And it probably does for me. You have a lot more flexibility, but also there are a lot of constraints with an existing system. Decisions have already been made and trade-offs have already been decided. So you have to live within that reality, don't you?
But Matt, are you ever starting from a blank page? The whole system also includes people and ideas and things that we want to improve.
I would guess that like when Matt says starting from a blank page, he means like, let's say you're a contractor and somebody says, I need you to build this brand new page. We generally have this like set of technologies that we're probably going to use out of the box. Like we might use a SQL database, a couple different things, and like we can just sort of set them up. Whereas if you're working at like a big corporation like a Microsoft or a Google or a Heroku, they probably have a whole lot of things internally that you're going to have to start plugging into and using however they are. Like you can't just go out and be like, oh yeah, I'm just going to make my own message queue and do all these things. Like chances are they have all of this there and you need to figure out which ones make the most sense to connect to. So I guess as a follow-up question, what I'd kind of ask is like, when you guys are in those environments, do you find things like in school you learn about like XML or not XML, like there's big diagrams, I forget the name of it, UML maybe?
UML.
Okay, so UML diagrams and all these things where you like design all this stuff together and you'll actually sit and write, a design doc that covers all the different things and how they're going to interact together. And I've done that before and found it useful in some projects, especially when I was first starting at Google. It was super useful because I didn't know about half the technologies there. So people could review it and tell me like, this technology would actually work better for you and swap these things out. But I found that later as I did more consulting type stuff and working on my own, that I kind of just went to a standard stack and designing that way didn't generally become as useful.
So let's start by basically saying that personally, I haven't used UML in I don't know, 15 years. Personally, I find it to be, let me not badmouth, technology that other people might still be using. It's just not my favorite. That said, I do use diagramming tools, and especially in the beginning, like I like to think of it in terms of a topographical map, right? There's different layers of detail that you're going to add, especially if you have to basically communicate, right, what you're thinking and your design. I think you kind of hit the nail on the head earlier, John, when you said that basically if you have to sort of talk to other people and show them what you're thinking, right, you're going to need some sort of some abstracted level, right, concepts to be talking about, right? You, rather than mentioning specific queuing technologies, you might basically say, okay, this symbol represents a queue, right? Rather than mentioning, okay, this thing uses Postgres or this thing uses Redis, right? Maybe you're just mentioning, okay, like database or cache, right? So you're learning to sort of think of systems, right, and not technologies, right, if that makes sense. So you have to be able to sort of articulate, right, and talk to your team about this is what I plan on doing, right? And that could go from sort of building and implementing a feature to designing large-scale distributed systems. So you have to be able to communicate, right? That's the key takeaway here. You have to be able to communicate to your team, and the level that's appropriate for your team is based on team dynamics, team culture, what folks are going to find most useful, but you have to be able to communicate. Personally, I start out with basically, like I mentioned before, I'll start out with a README. Sometimes I start out with a mind map tool. That's one of my favorite tools ever. I use it for everything. It helps me reason about what I'm thinking, right? And I can start seeing the different layers that are applicable to a design. And basically now then synthesize this into maybe like a quick little write-up. And then basically I might accompany that write-up. I might have boxes and arrows type of thing. And there are tons of tools out there to help you do that, right? So, Draw.io is one of my favorites. So basically having these things in hand, right, helps you communicate and helps you get feedback, valuable feedback that you wouldn't get otherwise. If I have to sit in a meeting and explain everything to you while you're trying to keep everything in your head, that's going to be very hard to do, right? So these tools exist to help you communicate. That's their value, right? Sequence diagrams are one of the best things invented, right? It's like these things help you with communication and getting feedback.
Yeah, it's funny you mentioned UML. UML, I think it was like an OO. It's very OO heavy as I remember it. You can model classes and subclasses and things like that and all sorts. And since Go doesn't really work like that, maybe there are some changes in the way that when we get to using Go, maybe there's some things that are different. Sandip in the Slack channel mentions the maxim of a little copy and paste is better than a little dependency. And this is a subject that comes up quite a lot. And it seems that the default position is that you just abstract it and have a dependency immediately. As soon as you notice you're going to use something again, that's the time to do it. And I personally have learned to resist that instinct and actually just copy and paste a few times first. and sometimes even just write a different version of it, something that's more directly specific to what I need right now. So it seems a little wasteful, but the problem, of course, is if you abstract too early, odds are you're going to get it wrong. You only really have one implementation in your mind, and so that's what the abstraction ends up mirroring and doesn't necessarily suit future cases. So how do you tend to go for the dependency early, or do you not mind a bit of copy and paste?
Personally, I don't try to refactor anything until I've seen the same sort of pattern like at least 3 times. So that's when I know for sure that, okay, this thing shows up here, here, and here. Like, again, like premature, that's because otherwise that's a form of premature optimization. You don't yet know what it is going to be. It's okay to copy and paste, right? And I don't need to abstract anything yet. I'm still trying to figure out what the thing is, right? But once I've sat down, I've seen it, come up over and over again, that gives me an opportunity to see, okay, is there a variance in how this thing is going to come up, right? Whereby if I had abstracted earlier, right, maybe I've painted myself into a corner, and now I have to, abstract again, and something that ends up looking similar but not quite the same as the first one. Like it's a premature optimization. Like, I don't do it.
I can say that even as an experienced developer, I think we still sometimes do this when we shouldn't. Like, to give you an example, I was recently messing around with some React stuff, and I decided to take some of the icons, like SVG icons I had, and just turn them into React components to make my life a little bit simpler. And in the process of doing it, I tried to generalize it so I could just, add in just a couple small path strings and, make all sorts of different icons. And I had 3 or 4 of them, so I knew there was at least some that had that. But later on, as I went through the project, and I actually started doing more and more, I realized how they all diverged enough that doing it the way I was doing it was not the right way. And you'd think at this point in my career, I'd know not to do that, but we still, I think, sometimes make those mistakes and have to backtrack on them and be like, yep, that was a learning experience.
Yeah. I also kind of tend to use the rule of 3 as the breaking point. And I also occasionally mispredict what's going to happen in the code base. So,
yeah, well, I think it's very normal. In fact, I have a feeling that we train ourselves really to look for these things, and we become too good at it, or at least too good at thinking we've found those abstractions. And yeah, I think it's something that's a discipline that we have to work on, all of us. Because I'm also tempted to do it sometimes as well, and it's quite exciting, I think, because what we're essentially doing is multiplying the value of what we're building. If you do find that interface in Go that just is the perfect sweet spot between the different implementations, especially if it's a single method interface, I get extremely excited about that. I can't wait to do it, and yeah, I have to take a step back. It is a discipline thing for me.
So taking a step back to when we were talking about, using design diagrams and stuff like that, Egon, when you said that you had to redesign the synchronization algorithm or that sort of project, was that something that, was it because the design diagram, you didn't come up with a good design up front, or was it just something where you needed to try it in different languages or different algorithms just to find out which one was most effective?
So there are different aspects. So the initial different prototypes were about just understanding the problem domain and space, how these different synchronization algorithms work. So I can more efficiently design the system such that it fits the rest of the things better. With regards to rewriting the actual implementation, the idea there is that since I was using different paradigm languages, so I was using functional programming, I was using JavaScript, which is kind of weird, Delphi, Go, and Prolog. All of these give me different insights into what is nicer and what is bad in one paradigm. But once you get this knowledge, you can integrate them into a single whole that is much nicer to read and understand. So you're gaining different insights because different languages have different restrictions.
So I guess coming off of that, for the rest of you, do you find that writing Go code allows you to essentially like design differently in any ways? I guess the best example I can come up with off the top of my head is I found that like I wrote Java a while back, and I always felt like Java, it was kind of a pain to come up with an interface of some sort. Like it was a very involved experience, it felt like. Whereas like in Go, one of the things I love about it when I'm coding is that if I'm writing some code that, a user signs up and I need to email them a welcome email and do a bunch of other things, I don't actually have to think about all of those other things. I can just, inline some interfaces or functions, whatever into my type that I'm doing. And I feel like Go makes that very, very easy. So I can make what I'd consider, it's kind of like a working prototype, but I don't have to think about the entire system. I can just sort of interface it away as I'm designing. So does that ring true for any of you?
For dependencies, absolutely, yeah. I think that's also a nice way to talk about the kinds of dependencies that you need. Like it's an opportunity to say, for example, if there's a big struct in some package, but you're only going to use one or two of the methods, you can take it as a storytelling opportunity to just have the interface that describes those two methods. And obviously, the fewer methods your interface has, the easier it is to implement. And therefore, the more likely the chance of it being implemented is. So, yeah. And I think Go's philosophy of minimalism and having fewer language features helps, because you don't have this big bloated toolkit from which to pull things. Of course, you can still write bad Go code and you can still get into a mess. But I think the minimalist approach and the philosophy for Go helps us a lot. In fact, especially if you pay attention to it and start to apply those principles yourself, I think all that really does help. And I think Go code, we talk a lot about it. I know that people that do training on Go, and if you spend time in the Go community, it's a recurring theme that you hear, this minimalism, shrinking things down and trying to focus. I think that as a philosophy really helps us in lots of ways.
Jon, so what I picked up from what you said earlier was that the Go in some way influences how you design software, right? It's not like we're basically taking some abstract concept and basically saying, well, we can simply drop it in this language and we just change the syntax and you're ready to go. And then you take the same thing, drop it in this language, you just change the syntax, you're ready to go. Kind of, it's the language sort of informs how you think about it, for better or for worse. I don't know if that's a good thing or a bad thing. Like speaking personally, and like for my own career, I think it has helped. I think, again, for that simplicity that you're talking about, Matt, but I don't know, like I think in the technology you use, I don't think folks like to agree, with what I'm about to say, but I think a lot of times, we identify a technology and we say, well, how can our problem fit into what that technology, the problem that technology solves, right? We may not agree or be willing to admit that, but sometimes that does happen, right? So, but I think in this case, if I'm being honest, I think Go has influenced the way I design software for the better.
Yeah, same for me. And honestly, they say that constraints can really encourage creativity. That I've heard that said before, that by having those constraints and having fewer options, you actually can drive up creativity potentially. And that means we think about, especially because the goal has to be simplicity. So we get to be creative about how simple can we really make this. I love that about Go. And I think you're right. It's done that for me too. And I think fewer options. I think in the next major release of Go, we should look at taking things out of the language and of the tool chain and things. There might be things that get added too, but there's some languages. I know that Swift, for example, if you look at the development of Swift, it's extremely powerful, but there's a lot to learn and there's a lot to do. And if we care about simplicity so that we can work together more easily, then for me, Go wins there.
Yeah, Go I think has been the most influential language in my design process in general. And I think one interesting thing I've noticed about Go is that bad Go code feels bad, which isn't the case for all the other or most of the other languages I've seen.
Yeah, that's a good point, actually. You can Go code can sometimes, I'll look at a repo and I feel like I wrote that code. That happens to me more in Go than any other language that I've worked in. And similarly, sometimes if you're a Java developer and you start to write code, you start by writing Java code in Go syntax. And it starts to look strange when you get used to Go. So yeah, I think that absolutely happens.
This episode is brought to you by our friends at Rollbar. Move fast and fix things like we do here at Changelog. Check them out at rollbar.com/changelog. Resolve your errors in minutes and deploy with confidence. Catch your errors in your software before your users do. And if you're not using Rollbar yet or you haven't tried it yet, they want to give you $100 to donate to open source via Open Collective. And all you got to do is go to rollbar.com/changelog, sign up, integrate Rollbar into your app. And once you do that, they'll give you $100 to donate to open source. Once again, rollbar.com/changelog.
So what about assigning work when you're working in a team? I've seen it done lots of different ways where teams, there will be like some kind of manager or tech lead who actually assigns work. And I've worked in teams where we take the work, like the dev team picks the tasks instead. Do you have any views on that and any preferences?
I think it partly depends on the skill of the team in general. If you have a senior member and many junior members, then assigning tasks out such that they can learn and like it's appropriate for their skill levels is beneficial. At the same time, of course, if you have all senior developers, then it's going to be so much faster if they can decide amongst themselves and kind of do it like ad hoc, essentially.
Yeah, I think that's probably true. In fact, I notice a theme here around context being quite important when it comes to the answer to any of these questions. It depends is often the answer. But when I've seen teams that have this take responsibility approach, I notice a very different kind of feeling towards the work. I've noticed that if you take responsibility for something, first of all, you know you've got it, versus it's just assigned to you, and it's some email in Jira and you might miss it, but you know you've got it, so at least it's in your consciousness. But it's a kind of automatic ownership and responsibility that you just feel for because you took this. Yeah, I took it, and if I can't do it for some reason and I need help or whatever, then of course the team should enable that. But you could put it back. You can say, okay, look, I took this, but it's beyond me. I'm going to need help with it or whatever. It's a great opportunity to then collaborate and spread knowledge and all that stuff. But I noticed this change, just a simple change of taking responsibility, really dramatically impacted how people felt about the work and therefore the quality of the work. Not to mention the natural selection of people picking things that they either have particular knowledge in or a particular interest in. That also can happen too.
Mm-hmm. I totally agree. If there is interest, if you get assigned the work, or if you get to pick the work that you have a preference towards, I think you'll probably enjoy that work more. But after doing this for a while, I've also seen sort of the negative side of that, right? So I've seen developers who sort of take on, a piece of a component or a piece of the architecture, and they're running with it. And if they don't have somebody sort of checking on them, they can sort of get into a sort of a rabbit hole, and they're afraid of coming back out to say, hey, you know what, I am struggling. I do need some assistance. Like maybe I bit on more than I could chew, or maybe there's this feels like I'm doing way more work than is necessary. Like there's a certain level of sort of humility that must also come with this sort of a responsibility. I mean, the humility must be part of the responsibility, right? So you have to be able to sort of basically put some distance between yourself and the work, right? So not have so much of an attachment to it, whether it's like, oh, mine, I'm the one who's going to work on this, or it's like, crap, like I bit off more than I could chew and I can't finish it, right? But I'm not going to talk about it, right? So you kind of have to know enough about yourself and your tendencies to be able to step back and say, you know what? I need help. Again, raising your hand, communicating with your team. And really, ideally, you're in a team that's not going to judge you for that, right? That they are willing to help you and pair with you and have a conversation with you, hopefully about your high level design if you have one. I mean, that's ideally, those are the team that function very, very well, and not just getting something in an email, like a Jira email says, hey, you've now been assigned to this thing, right?
Yeah, well, that's the thing about, that's another thing that the team needs to decide. If you take the responsibility for something, that doesn't necessarily mean you have to do all of that on your own, and the next time the team hears about it, it's done. Absolutely not. You're really just taking the lead on that particular issue or that task. Yeah, and then the team, we're there to support each other, and the team wins or loses together. There is no individual kind of heroism within teams. They never do it lazy. No, they work very hard and do a great job. Yes, but you win, you succeed or fail as a team. So just by taking the responsibility, really what you mean is, I'm going to take the lead on this, and I'm going to for sure seek help where I need it to get this across the line. I think that's right. That's the right kind of approach to it for sure.
I suspect this is also why teams that have worked together a lot more are, even if they're not like composed of the like best engineers, are still better than like if you took the best engineers you knew and threw them all together and they've never worked together. And I'd say that in the sense of, you get to know what people can handle, you get to know like what their workloads are, and if you're going to need help. Like, so let's say I really want to take on some new project because I want to learn this new thing, but I'm like kind of worried, like, if I need help, I'm going to have to go to Matt to ask for help. I think understanding that, talking to Matt and being like, what's your workload like for the next couple of weeks in case I need to, sit down with you a couple of days. Because if Matt's really, really busy, then that's probably not going to be a good idea. But on the other hand, if Matt's like, oh, I can set a couple of things aside and we'll be golden, then, as a team, you can decide these things. But it really requires you, like as Johnny said, you have to have a team that feels like they can openly discuss these things and actually tell each other, there's a chance I might not be able to do this, or I might need help, or I might have to rely on you a little bit more than somebody else might have to.
Yeah, absolutely. And for me, it's clear that the answer really has to be that it would never be, no, I'm too busy, because we want to succeed. So part of everyone's role is to support other people in the team. And actually part of this taking responsibility idea, it also has a built-in kind of rate limit. If you're working on something, that's taking a long time, you're not going to then also be taking new work. So you kind of get natural rate limiting and things as well as part of it. I really have seen a lot of benefits to just that simple change of having people elect to do the work rather than just have it assigned to them. Okay, so what about estimation? This is probably a major subject in its own right, but I don't think we're very good at predicting the future. I don't think we are good at knowing how long things are going to take. Most of the time, we haven't built this thing before. If we've built exactly this thing, then maybe we've got a good chance of having a good estimation for when it's going to get done. But most of the time, aren't we building new things? That's our job. So I find estimation to be somewhat of a troublesome aspect of what teams are asked to do. And the trouble is, of course, lots of people will be very confident and tell you when something's going to get done by, but I'm not sure that they know any more than I do. How do you three feel about it?
I was having an internal chuckle because I'm like, I don't feel qualified, even with 20 plus years of experience. I don't feel qualified to talk about this because it is literally the thing that has plagued my entire professional career. Like when I think something is going to take X amount of time and I end up doubling or tripling it because, like you're saying, it's like there's an element of predicting the future there that you simply do not see coming. Like even if you were to do the big design up front, which unfortunately some teams still do, you just, there's no way you can, sort of see what's coming, especially if you're going to get feedback right along the way, right? If you isolate yourself and say, okay, here's a set of requirements, right? From day one, I'll see you in 3 months, right? You might come out on time, right? If you're lucky, but there's a pretty much a guarantee you're going to come out with the wrong thing, right? Because you didn't get feedback along the way. So it's like if you're trying to do the right thing, there's a sort of a negative feedback loop there, whereby the more input you get on the way to getting the right thing, the more it sort of deviates from the original plan. So I've basically sort of, I don't know, I basically throw up my hands and be like, look, I don't know what this is really going to take.
Yeah. Well, you see, I think the problem is this question gets asked, and people who ask it with a very straight face, as though it's the most normal question in the world to ask. Yeah. They'll say, well, and how long is that going to take? And unfortunately, it's rare that you will say, although it's rare that teams will say, we'll basically question the premise. That question in itself is very complicated. That's one of the things I like about iterative development, is you actually start seeing results much sooner, and that is a different approach really to this idea of, okay, we're going to have it done in a month, and then I'm just going to go away and be on my own for a month. Doing the iterative thing, you can kind of get a sense for the progress of it and how long it's going. And it also comes down to trust. If you have to really trust the development team that they're not going to just waste loads of time doing nothing, that they are going to be doing this, and this is a focus and things. And I think a lot of the time these things come from a time when there either isn't trust, or just that the philosophies are all different, and like, it's from a waterfall or something, a waterfall design or process or something like that. What about you, Jon?
I mean, one of the biggest issues I always have with estimation is that there are so many unknowns that it's kind of like, somebody says, hey, can you can you deliver this package across a river? And you're like, well, how wide's the river? How fast is the water running? Is there a bridge? Do I need to build a boat? There's all these different things that you don't know until you get there, and they're just expecting you to know, here's the time. So I feel like I tend to have better luck at this whenever I can actually dig into a project a little bit more with some prototypes and that sort of thing. But the hard part there is that sometimes you don't even know how long that prototype's going to take you to actually really understand things. So it's like this cyclical problem where it's like, I can't really tell you. But I do think experience helps a little bit, in the sense that you start to, I don't know how to describe it. It's not that you actually know. It's more that you're better at judging whether or not there could be some pitfalls, or you're better at recognizing potential pitfalls. But that doesn't mean you're going to actually recognize them all, or you're going to be perfect. It just means that you're smart enough to say, I don't know fully, so here's my padding or something. But the downside to that is that you end up with teams who, they have a bunch of tasks that all in reality take an hour, and everybody's saying, oh, these are each 4-hour tasks. And then you have management pushing back, like there's no way that's the actual development time.
Yeah, I worked at a place in London where the minimum time estimate for a task was 1 day. So there'd be a task to change this URL somewhere, and that would be a day. And then another task is to change the text in that same link. That's another day. And this company got used to just these massive, slow-moving things. And then that slows everything down. The actual engineering teams worked at that pace then. And it was the most frustrating place I've ever worked, because I like to do iterative and deliver things very quickly, but deliver less. One way to be a 10x developer is to divide the work by 10 and just do a really good job on a 10th of that. And then end of the week or a couple of weeks later, you can do demos and you can show and things. And for me, that's a much nicer way. It's a much better conversation to be having, rather than trying to predict how long it's going to take. And like you say, Jon, building in padding. I like to just be completely honest, just basically generally. And I feel like padding is dishonest a little bit. I understand it completely. And by all means, teams, if you have no choice and you're being forced to do estimation, then yeah, of course, there's going to be padding, because actually that's uncertainty. That's what you're doing, is adding in an uncertainty buffer for yourself. And that's the other thing. If a task is uncertain, or there's a lot of uncertainty around a task, you should estimate it much, much bigger. Because that's really what we're saying, is how certain are you about this thing? And the answer usually is not yet. Plus, as you're actually doing the work, new ideas are going to happen. New ways of thinking, or a bit of creativity, something might spark, or you might see something else that where you think, oh, I didn't realize we had this. We could use this to solve this problem as well. All that stuff, and that creative process should be allowed and should be encouraged, not discouraged. And I feel like having these strict estimates and even designs that are quite strict, I feel like that's not good. I prefer tasks that talk about problems. So, that's why I quite like use cases in the agile world, where they're actually focusing on, this is a user that's trying to do something and this is why. Even those get misused a lot, but yeah, definitely that's the important stuff. And just this automatic kind of cruise control of, give us an estimate and we'll know when it's going to be done exactly, which, by the way, is barely ever right. Managers must have noticed these estimates are barely right. So I don't get it. I prefer to say we don't know, and I think we should, us for now, should give permission to junior developers to say we don't know, but nobody does.
So here's something I picked up over the years, right? So in the beginning of a project, right, if you're working on a greenfield project, I believe it's a lot easier to provide estimates and sort of have and somewhat be, within an order of magnitude, like, close enough, right, to your original estimate. But over time, especially once the software gets released, it goes through a few iterations and things are being added. There are a few more dependencies between things. It does indeed become harder for your estimates to be right, because there's just more stuff there. The software package might be larger, so it's no longer just about making your change. It's about making your change and it interacts well with other changes that the team is putting in. Maybe it interacts with other systems that are themselves changing and evolving. So what you think you're committing and that works right in your local environment goes and breaks during integration testing. So there's a lot of variables, right? And it gets worse over time as when you add the element of time, right, to any production system. So yes, we can definitely advocate for juniors to sort of feel free to say, hey, you know what, I don't know what this is, and that's absolutely right, because if they're junior and they're sort of still getting experience in terms of sort of knowing what something should or shouldn't take, that's perfectly all right. But I think we should sort of be empathetic, right, to some degree, for the senior engineers who are working in large systems where their estimates is not the only thing that can be factored in. So it's managers do indeed have to add, not necessarily, I don't think they would call it padding. It's more like maybe if there was a manager on the call, they'd probably have a name for it, but I'm sure it's some buffer, some degree, basically, of saying, the typically what we're seeing from sprint to sprint or from release to release is that the team estimates, this much work is going to get done, and there's typically, about 1.5 times that, right, to actually get a release. So they get a pretty good idea of what it is, what the team velocity is in terms of being able to sort of get through features and whatnot. So they know how to sort of account for that, and that helps with planning releases. That helps with product and marketing and all that stuff. So there's a lot of things like around that, right? But I think the element of time, which really screws everything up when you add time to it, right? Whether it's the package you've got right now, which is going to evolve, or the piece of enterprise software that you're working on, which is also evolving. It, like, when you add time to that, then it makes everything, including estimation, makes everything harder.
Egon, we haven't heard from you re-estimation, sir. How long is it going to take for you to give us an answer?
He's estimating.
A little. I think there are tasks that you can fairly well estimate in hours. But yeah, there are different things happening usually in the company, or something else comes up. So you get disrupted, and that pushes it out even more. So if I ask you to, let's say, add a new description field for the user, that process might be really well estimatable. However, implementing new things that you've never done before, you can be wildly off. I spent a lot of time maintaining old legacy systems, so different things became such that I could pretty much estimate things like 30 hours. Let's say it's 30 hours, and it was like plus minus 1 hour. And then there were things that I just were like 2 times off. So, and I don't think it's just coincidence in that sense. So tying back to the knowing when you're being imprecise with your timing.
Yes, that's the thing though. If you can estimate some things accurately, should you? Because that plays into this belief outside of dev that you should know how long things are going to take. But you're right, absolutely. There are sometimes, if it's like that, we're going to add a new field, and even if we have to touch a database and the user interface and the API, you can probably fit all of that in your head and have a relatively good idea about it. And I think I've seen I quite like the idea of I've seen this t-shirt size thing done in Teams where they say, that's a small, this one's medium, and then this one's just large or extra large, such that it needs breaking down, or we need to do a spike to understand it more. I quite like that because it's kind of a little bit more open about the fact that this is a very imprecise estimation. And here's another thing, though, by the way. Whenever anybody says, and don't worry, this is not taken literally, just do a best guess. No, it's taken literally. It's almost immediately taken literally. And that's why I am now, and I'm quite lucky, I'm in a position now where I can push back, and I usually use it as an opportunity to sell this idea that, tell you what, instead of trying to estimate this, let's pick a date and I'll give you a demo and you can see what we can get done in that time, and we'll get done as much as we can in that time. But I'm not going to tell you what's going to be done. The scope is going to change. And if you can get that, I think that's the way to do it. Because fixing scope and fixing time leaves only quality as the lever that you can pull. And we should always be writing high quality code, I think.
So a question for you then. If you're going with this, here's the date, we're going to do a demo and we'll see how much we have done. How does that play into your decisions for, like, sometimes you can do some work up front that will help some features come along, but they're going to slow down current stuff for like the demo. Do you think that has an effect on how you design your systems and how you write code that way?
Well, generally, I try and do a tiny piece of whatever that work was. Sometimes, it's unavoidable, and there's a lot of foundational work to do. But often, there's a little slice of that foundation that you could build first and build it out later. You know what I mean? So I really like this idea of delivering things in vertical slices rather than big foundational project to get the API ready and the back end, and then a big project to get the front end working. I'd rather see a bit of the back end and a bit of the front end, a bit of everything working and useful. And honestly, we did it with Machinebox. The original versions of our boxes for Machinebox were very lightweight, cut down feature-wise. They had a very small scope. You could just do a couple of things. And there's a lot more we could have done with that, but we were kind of a bit obsessive over this, keeping it minimalist. And this came from the Go philosophy, I think, and from the whole kind of agile movement really talks about this. And it was so good. We got it quickly into the hands of real people. And then we started getting questions like, how do I, like in Facebox, how do I remove a face? How do I delete a face? And we didn't have a way to delete a face. We'd say, restart the Docker container and don't teach it that face. Teach it all the other faces again. That was our solution, which is, fair enough, I suppose. And in most production environments, that's actually okay because that's how these boxes were going to be used. But we did add delete faces as a feature, and it became an obvious thing once a few people had started asking for it. So yeah, I advocate for that. Sometimes though, you have to just make a call, and you might delay the initial releases. The initial demos might not be as good as you want them to be. But it comes down to trust.
I ask because I worked on a project once where essentially the new features that needed to be added all required a major database redesign because the way it was set up currently could not support the features, and we couldn't just do quick migrations because it would lead to massive performance issues. So we had to basically take a lot of things into consideration as we were doing it, which made it this really, really long project that ended up taking several months, I think, to actually completely finish the whole thing. But it was one of those ones where had we just tried to iteratively show small demos, I feel like it would have been bad. Because I could have shown a demo with most of the new stuff working, but it would have been in this isolated environment with a very small data set, it works fine. But if you throw in all the data, then some users are going to sit here waiting for a page to load for 10 seconds, which is not acceptable.
Yeah. Yeah. Well, honestly, if you do know things up front, then I'm not saying you just don't act on your knowledge. You'd still take action based on what you actually know. My argument is most of the time you don't know that much up front, and you learn most of it by doing it. But yeah, in some cases, in that case, it sounds like it was clear, was it? Or did you have to go through a big design process?
We had to do some things to sort of prove certain things would have performance issues, which is what made that very, very hard, and what made the process long was that it wasn't clear from the onset, if we change it to this, is it actually going to have those issues, or is there ways that we can get around that? So it took a couple iterations of figuring out the correct way to set up the data, looping back with customers and making sure that whatever trade-offs we made were going to work for them. Because that was the other part of it, was that some of what we were doing was depending on what customers for the application needed versus what was easier for us to do. So it was just a very long process in that sense. And it's one of those ones where estimating that, even today, if I was sat down having done the whole thing and had to estimate it, it would be very hard to give a fixed estimate, because it's it depends on so many things that it's just really hard to do.
Yeah, I mean, it sounds like you did it the right way. It sounds like in that context, what other choice did you really have? Yeah, and again, I think that's a kind of a theme that I've noticed, is that it depends. There isn't really a right or wrong in this either. In some cases, it's going to be... building software is hard, and it's almost impossible, and somehow we still have some software, so it must be possible. That's just how I end up. That's where my reasoning always leads me. Anybody else? Final thoughts? We're almost at the end of our show. Anything else?
So the last thing I'll add there, because, and in part because of what I've been doing for the last couple of years, and basically being involved in more on the operational side of delivery of software, if you will, we definitely shouldn't engineers or rather the folks who are developing features, right, who are building things that users are going to end up interacting with, or other systems are going to end up interacting with. You have to, the design process should involve should involve the sort of how the software gets delivered, how it actually gets in the hands of the people who are going to use it, or the systems that are going to rely on it. It's not enough to simply design features. It's not enough to simply design sort of what folks see and do, and it's not enough to worry about just the interface or just the database performance and this and that. So you kind of have to look at take a holistic view, right, of the entire system, from how much bandwidth, right, does the system have, right? What's the communication between components like, right? So all these things have an impact on your system, especially the higher stakes, the piece of software, the more these things are going to matter, right? How fast are your disk, right? I mean, things that as an engineer, you're as a basically somebody who's developing features wouldn't think about. Sort of I have an appreciation for that stuff now, having sort of seen on the backside sort of all the things that sort of go on to deliver high performing sort of software. Like, I think this is something that as a software engineer who's writing software and working on features, the more of these sort of what goes on behind the scenes, the more of that stuff you know. And I'm not talking about full stack. Full stack these days seems to just mean that you can just write an API or connect the database to the back end and also write some front end. Perhaps we can rename it full stack or something. I don't know, whatever name you want to give it. Like, if you, the more you know about what happens, right, when your software gets delivered, the more you know about what happens when it goes on a cluster, the more you know what happens once it's containerized or when it's interacting with other components, right, at the network level. Like, the more you know about that stuff, the more of a better, like, the better engineer you're going to be, right? And this is something I've noticed sort of my own skills sort of level up, right? Because the moment I started paying attention to these things, then how I design software also improved, right? So it wasn't just about the language. It wasn't just about, some new best practice I picked up, some architectural design kind of thing. It was also about, okay, care about what happens when your software is running. How does it get operated on, right? So these things all make you sort of a better engineers, and they are part of the process as well. So that's sort of my takeaway from this.
I'm so glad you said that. That's such a good point. And it doesn't mean that new developers need to know everything before they can be useful. But you're absolutely right that, the more you know, the better. That also applies the other way from the user and the customers and what problems they have and what they're doing and what their day looks like and where your software fits into their day. That kind of stuff on the other side too. The more you know, the better. And we do have to divide and conquer, of course, and we're a team and we're going to have different interests and different strengths. But Johnny, I couldn't agree more. The more you know about this stuff, the better. And we should also, therefore, as well, don't be too protective of your domain. Welcome people in and share your knowledge as well, because everything's going to get better if we do that. What a great point, Johnny. That's really made my day, mate. Yeah, right. I think that's our show. We've actually run a little over. This show's kind of awesome because we just have these conversations, but we're actually spread all over the world. Where is everybody at the moment? I'm currently in London. Johnny, where are you?
I am the closest city you might know is Baltimore, Maryland.
I do know of that one. It's in a movie called The Sum of All Fears.
Yeah, that one.
Yeah, that's a film in which a nuclear device explodes in Baltimore. And John, I know that you were disappointed to learn that The Art of Execution wasn't actually about corporal punishment.
A little bit frustrated. I thought that's what you invited me here for. I was doing research.
Yeah.
No. That sounds really morbid. I am in Pennsylvania. The closest town or city people know of is probably Pittsburgh or Harrisburg, but they're both like 2 hours away.
Ooh. Forget how big America is sometimes.
Yeah, some of us live in the middle of nowhere.
Yeah. And Egon, are you in Estonia at the moment?
Yeah, I'm in Estonia. Closest city you might know is Tallinn, but I'm in Tartu, actually.
Nice. I mean, isn't that amazing that we can just have this conversation and make a podcast together and we're spread out all over there? And extra points for Egon for doing this in another language as well. I'm always blown away. I was at GopherCon EU, and I'm so genuinely blown away by how effective people are communicating in a second language. Same for you, actually, Johnny. Right? We talked about this. Yeah, there's a joke that somebody told me, and they said, "What do you call somebody that can speak 3 languages? Trilingual. What do you call somebody that can speak 2 languages? Bilingual. What do you call somebody that can speak 1 language? British." Oh, it's such a burn. It's such a burn, but it's correct. So anyway, just want to say that. Blown away by everyone and the amazing communication skills in other languages. So that's it for our show, and what a great one it was. I learned a lot, and I hope you did too. We talked about the art of execution, how we actually get things done. And it seems to me that there are some things that are good practices, but by and large, it really depends on lots of other things. It depends on your team, it depends on the kind of thing you're building. If you're working alone, if you're working in open source, that changes things too. And also, there probably isn't a right or wrong way. So it's about exploration and find out what works in your context. And that's how we can keep building excellent technology. Well, and that's it. We'll see you next time on Go Time.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us in Gopher Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.